Welcome to the in-depth tutorial on machine learning. Today we are diving into one of the most foundational yet powerful topics in predictive modeling, multiple linear regression. By the end of this video, you'll not only understand the theoretical underpinnings of multiple regression, but also know how to implement and evaluate it in Python using real-world data. Let's begin. Multiple regression is a statistical technique used to model the relationship between a dependent variable, the one we are trying to predict, and multiple independent variables, also called predictors or features. Unlike simple linear regression, where there is just one predictor, multiple regression allows us to account for the influence of multiple factors on an outcome. Imagine you are trying to predict house prices. Square footage, the number of bedrooms, and the stories of the property could all contribute to the price. With multiple regression, we can incorporate all these factors into a single model to make more accurate predictions. In mathematical terms, multiple regression fits a hyperplane in a multidimensional space where each dimension corresponds to a predictor variable. The equation for the model looks like y equals to beta naught plus beta 1 into x1 plus beta 2 into x2 up until beta n into xn plus epsilon, where beta 0 is the intercept, beta 1 and beta 2 and so on are the coefficient representing the influence of each predictor, and epsilon represent the residual error or noise. The model works by finding the values of these coefficients that minimize the sum of square differences between the predicted and actual value. The process is called least square estimations. Before jumping into implementation, it's important to understand the assumptions underlying multiple linear regression. Linearity. The relationship between predictors and the response variable should be linear. For instance, doubling the square footage should roughly double the price. Independence. Observations should not influence each other. This is critical when dealing with the time series or spatial data. Homoscedasticity. The variance of residuals, the difference between actual and predicted values, should remain constant across all levels of the predictors. Normality. Residuals should follow a normal distribution. This ensures reliable inference about the coefficients. Now that we have covered the theory, let's put into practice by building a multiple linear regression model in Python. First, we import essential libraries. NumPy and Pandas help us manipulate data. Scikit-learn provides tools for modeling, and we'll use metrics like mean squared error and R-squared to evaluate our model. Next, we load our dataset, which contain information on houses, including their lot sizes, number of bedrooms, stories, and prices. We extract predictors into X and the target variable into Y. We then split the data into training and testing sets. This ensures that we can evaluate our model's performance on unseen data, preventing overfitting. Using the training data, we fit a linear regression model. This step calculates the optimal coefficient for each predictor. Once the model is trained, we use it to predict house prices for the test set. Finally, we evaluate the model's performance. Mean squared error measures the average square difference between predicted and actual value, while R-squared indicates how well the model explains the variability in the data. And there you have it. We explore multiple regression in depth, from understanding its theory to implementing it in Python. I encourage you to try experimenting with different data sets and see how multiple regression can solve real-world problems. If you found this tutorial helpful, don't forget to like, share and subscribe for more machine learning content. Until next time, happy learning.